Hey, just trying to go over some basic measurement tools. By now, everyone should have heard of a ruler. Um, Pretty common. You should have learned how to use one of these in grade school. If not, each one of these markings represents a fraction of an inch. This happens to be a ruler in inches. You also have rulers that are in metric or centimeters, meters, millimeters, etc. But in the US, the most common by far is going to be US imperial units, which will be inches, feet, yards. So, as you can see, looking at 1 inch, it's subdivided into halves. The first half would be half of an inch. The next division of that is going to be a quarter of an inch. After that, eighth of an inch, or 0.125. And then it goes down to 16ths, 32nds, 64ths, and so on. Pretty much you won't find any past a 64th. To use, you simply measure from one point to another point. For instance, if I wanted to measure how long this protractor is, I would start and measure, and I'll get 3 1/4. However, on the end of most of them, it's beat up, or on the end of most rulers, it's beat up. So it's advised to start at 1 and then subtract an inch from whatever your final length is. Also, the paint chips off. Going off of that, there's tape measures. This one happens to be in inches/feet, and then centimeters/meters. If you don't know, 100 centimeters is 1 meter. 10 millimeters is 1 centimeter. Metric's really easy because it's base 10. As far as US imperial units, inches and feet, it's odd because inches are, or 1 inch is 1/12 of a foot. A foot is 1/3 of a yard. There's approximately 16 feet in a rod, and there's so many rods in an acre. But same idea. You start off on the end, measure off to whatever point. This works better with 2 parallel surfaces. Fairly straightforward. You got the same subdivisions up to, on this one might be 30 seconds offhand. I mean, I'm just doing this video kind of quick. But the other thing that you should know how to use is a protractor. If you remember in elementary school or whatever. Each one of these little marks is 1 degree. Or if you want to think in radians, you can do the math. It's 180 degrees is equal to 1 radian, so you can do some unit conversions to get that. So it's 2 pi for 360 degrees. So, as you can see, the major intervals are marked out in 10 degree increments. Then it goes down to 5s and then 1s. There are different protractors that will measure down into minutes and seconds, but I do not have one of those with me. Alright, moving on to slightly more advanced tools of measuring. We have what is called a caliper. So, rule number 1 is you always make sure it's zeroed and that the measuring surfaces are cleaned. On this, there's actually a couple different measuring surfaces. there's between these two faces, there's this face and that face, or there's a distance from this end to right here. All three of those spots will be the same distance. Ooh, this is way out of calibration. Anyway, I only have US units for calipers except for a digital one, but how this works is you've got tenths of an inch laid out up, and it goes up. This one happens to be a 6-inch caliper, but there's tenths of an inch here, and then I'll just spin this. On the dial, this is called a dial caliper. Each division is 1/1000th of an inch. To give you an idea how small that is, a piece of paper is typically about 7/1000th of an inch thick. Now there will be times we go down to a tenth of that, or 1/10,000th, commonly referred to as a tenth. Also, going back to that, 0.1 inches is commonly referred to as 100 thou. So going back to reading the dial, where this is at, it'd be 3, or 0.3, there's 10, and there's 15. So it'd be at 0.315 inches. That'd be this surface to this surface, between the jaws, or on the tail end. To use, at least the jaws, you have your two parallel surfaces, and you simply squeeze, and then you read the scale and the dial. Conversely, if I wanted to measure a height, if I had like a flat plate, or height or like a depth of a hole, I could use the end and then bring that down so I have my two parallel surfaces. Or if I wanted to measure the inside of something, such as this magnet, I can bring out the two surfaces. So it's measuring in between this surface and this surface. I can do the same thing with these little holes. I can measure the thickness. I can measure the thickness this way. It's a pretty versatile tool. The thing you have to remember is your measuring surfaces have to be clean. By measuring surfaces, I mean the surfaces that you're contacting whatever part to measure has to be clean. That's both on the whatever measuring tool you use and your part. So this is the dial caliper. A variant of that is a digital caliper. This one, you can change the units between inches and millimeters. Convenient. If you don't know the conversion offhand, 1 inch is equal to 25.4 millimeters. With these, in general, the more money you spend, the better quality. So for measuring instruments, your three big companies are Mitutoyo, based in Japan, you got Starrett, and then you got Brown & Sharp. All three make good stuff. It has the same three surfaces for measuring, or the same three pairs of surfaces for measuring. So, in general, those are good for just about anything. However, if you're measuring material thickness or trying to get more accuracy, you're going to want to use something called a micrometer. It looks like a clamp, seems like a clamp, but it's actually a precision measuring instrument. Now this is an old one, so you might not be able to see the writing, but it's marked out in thousandths of an inch around the circumference of the knob that you spin. And then every hash mark is 0.01 or 0.025 inches, or 25 thou. So there's 25 thou around, and I believe it's 40 turns per 1 inch. And then tenths of an inch, or 100 thousandths of an inch are marked out. To use, you bring the two surfaces onto the surface you're trying to measure. For instance, this diameter. You look at the knob, see where you're at. I just happen to be at in between 15 and 16, or 14 and 15 thousandths. I add that to 100 thousandths of an inch, and I get 0.145 or 0.114 or 0.115. The nicer micrometers will have tenths marked out on the side as an additional area to measure. These come in different sizes. So this is a 0 to 1 inch micrometer. Now we have a 1 to 2 inch micrometer. 1 inch travel, same two surfaces. This one's got a ratchet to help it stop with the right tension. A variant of that is an inside micrometer. Again, same concept. For measuring inside of spots like slots and holes. This one you can extend on either side by unscrewing the caps and then screwing on whatever extension on the one or two ends. So, what if you are trying to measure runout or cylindricity, or trying to do a quick comparison? You can use some of these tools for, quick measurements, but trying to measure cylindricity, or if you have a height stand set up, you kind of need something else to measure. And that's where we had indicators. So this one, you have to be very careful with indicators. The needle can often travel multiple times, even if it is supposed to only have one revolution of travel. So we look at, see what the markings are rated in. This is in thousandths of an inch. So every mark is 0.001 of an inch. Every bold, or every number you see is, say, 50 thousandths or 10 thousandths or 40 thousandths of an inch. And then over here, this secondary dial will give you 100 thousandths of it, or every 100 thou of travel. There's different amounts of travel. The big thing is this surface the little ball on the end needs to be perpendicular to your surface. What happens is, with the test type indicators, this is a test type indicator, this is a drop test indicator. What happens is, your cosine of whatever angle your indicator needle is at will affect your accuracy in your reading. As a general rule, you want your needle either parallel to the surface or vertical to the surface. But if you wanted to measure like runout, this would be the tool to use. Or these would be the tools to use in addition to bench centers, which I do not have. So that should be a brief overview of precision measuring instruments, and just measuring instruments in general, if you know, if you don't know. I can go into detail more how to use these. I use these every day. People who work in manufacturing, such as manufacturing engineers, quality engineers, machinists, machine operators, tool and die makers, inspectors, all should know how to use these. These tools are essential to those trades. If you're not making parts within print specifications, you might as well not be making parts. Anyway, thanks for watching. Hit like if you like this, subscribe if you want to, and such other things. Have a good day.